Hi, in this video we are going to talk about array implementation of stack in Java. So we need to design our own stack and we are calling it myStack class. So we need to write code for myStack class and this is how this myStack class is going to be used. So we can create an instance of myStack class and this 10 parameter is capacity of that myStack. So first implementation that we are going to do is we are going to use a simple vanilla array, right, where we will provide the capacity and in the constructor we will create an array of that capacity. Later we will talk about a dynamic size stack which will be built using array list. So here we will assume that we are going to use a simple array. So we need to provide capacity initially. So let's say user provides the capacity 10, then internally it will create an array of size 10 so that you can add 10 items, and this class is going to assume that you are not going to add more than 10 items. So we have first created an empty stack of capacity 10, then we are adding certain items to this stack. We first add 5, so stack should become this, then we add 15, stack should become this, then we add 25, stack should become this. So we need to write a constructor, we need to write push function, then we need to write peek function. When you call peek function, it should give you the top item of the stack. So it should return you 25. So the print value here should be 25. Now when you call pop function should remove the top item and should give you the top item. So far we have talked about constructor, push function, peek function, now pop function. So pop function should change the stack and it should return the top removed item. It should remove the item. So peek also returns the top item, pop also returns the top item. The difference is peek function does not modify the stack, pop function modifies the stack. So here we have used push again, which adds 35 to the stack. See, after pop our stack became this, 25 was removed, and after push our stack becomes this. Now we are calling size function. This is again a new function. It should tell you how many items are there in the stack. So size and capacity are two different things. Size tells you how many items it has, capacity tells you how many items it can have. IsEmpty function returns a boolean value. It returns true if a stack contains no items, if stack is empty, otherwise it returns false. So stack has certain items here, it has size 3, so it's going to return false. Now please pause this video and try to design this class myStack that supports all these functions and that can be used this way. Here is basic implementation of myStack class. Inside this class, we have members which are array, capacity and top. So capacity is capacity of the stack. Now what is top? Top variable we are going to use to keep track of the index of the top item. Since there is nothing initially in the stack or array implementation, right? We have this array initially, which is initially empty, nothing in the stack. When you create a stack, 5 is the capacity, so we have 5 cells in this array. Initially, we are going to have top as -1, right? Because it's not a valid index, right? So inside the constructor, we initialize top as -1. We initialize capacity as the provided input by the user. Then we create an array of the given capacity, right? So that's how we write the constructor. Now, how do we write the push function? See, if you want to add an item 10 to this stack, what you will do? You will add the item at index 0. And how do we get index 0? We do top +1, right? So we first do top ++ so that pushed item is at the top index, right? And then we add the item at the index 10. If you do one more addition, one more push operation, then you will again do top ++, top will become 1 and you will have the top item, right, at the top index. You will have the recently added item at the top index. So push function simply does top ++ and does array top equal to x. Now how does pop function work? Pop function needs to do top -, opposite of push, right? It should remove an item and it should return the removed item. And since we need to return the removed item, we first store the item to be removed in a variable called result, right? RES. Then we do top -, and then we simply return result. So if you do pop from here, what is going to happen? You are going to first store 20 in the result, then you are going to reduce top by 1, so your top is going to become 0 and then you are simply going to return 20. So that's how pop function is going to work. Now size function, size you must have guessed, it's simply going to return top +1. So if top is -1, size is 0, top is 0, size is 1 and so on. Now is empty function, it's again simple. If top is -1, then stack is empty, otherwise stack has certain items. So we simply return whatever this expression returns. If this expression returns true, we return true, otherwise we return false. So this is basic implementation, and this is how we are going to use it. First, when you create an object, you have an array of size 5, then you push an item, this is added here, push an items added here, then you pop an item, you remove 20 and your array becomes this. When you push an item, your array becomes this. This line is going to print the output as the popped item, which is 20. So output of this program is going to be 20 only. You can do other operations as well here. If you get the size, if you call size, you are going to get the size. Suppose at this moment I call the size, I am going to get the output as 2. And if I call isEmpty function, I am going to get the output as false. The basic implementation that we've just discussed, it has certain problems. The first problem is it does not handle overflow and underflow. Now what is overflow and underflow? You created a stack of capacity, say 5. Now if you add more than 5 items, that condition is called overflow. And what is underflow? If you create a stack and initially it does not have any item and you call pop on it or peek on it, right, that will cause underflow because stack is empty and you are trying to get the top item or you are trying to remove the top item. So those are underflow cases. How do we modify this class so that overflow and underflow are handled? See, what we can do here is we can put some conditions here. So we can say if top is equal to capacity -1, that means the stack is full and you are trying to add a new item. And when this condition becomes true, we can write some code to handle this condition. See, there are multiple ways to handle this error. One is to simply show an error message using system.out.println. Other is to write something in the error log. And one more way is to throw an exception, right? So there can be multiple ways to handle this error message. And standard Java libraries, they throw exception in most of the cases. Now, if you see the pop function, what is happening in the pop function? We are simply taking out the top item, reducing top and returning the result. Now, if I want to handle the case that if somebody is calling pop function on the empty stack, then what we should do? We should say if top is -1, then we need to write some code to handle that case. Again, there can be multiple ways. You can simply show an error message and you can return some special value after the error message. Something like integer.max value, an infinite value to indicate that something is wrong with the stack, right? Or you can throw an exception as well here, right? So there can be multiple ways. Now, so this is how handle we here. Now in the peek function, I have written the peek function here, and this peek function is going to give you the top item. How do we handle error here? Again, we can write a condition here. If top is -1, right, then we can handle it by writing some code here, right? Because we should not be calling the peek on an empty stack. And we can return a special value. If we're not throwing an exception, we can return a special value like integer.max value to indicate that there's something wrong. So this is how we can handle those overflow and underflow issues. The second problem with this implementation is there is no dynamic resizing. So if you create a stack of some capacity, you can add only those many items. Ideally, what you would want is you simply want to create a stack without worrying about the capacity, and you want this stack to dynamically grow and shrink when you are adding or removing items. But in this pure array implementation, simple array implementation, we are not able to do it because we need to have an array of fixed size. So we can handle the second problem by using an array list instead of array as an underlying data structure. So please pause this video and try to write down my stack implementation that uses array list as an underlying data structure. And with array list, you don't have this dynamic size problem. And you also don't need to write a constructor like this, right? You can simply have a default constructor and you can create an array list inside this. So please pause this video and try to write down the implementation. Here is an array list based implementation of MyStack class. So we have created an array list, and what are the advantages we get with array list? We can use dynamic size, right? In fact, I can further extend this MyStack class so that it can be used for any data type using Java generics, which is slightly advanced concept. So we created an array list of integers and we wrote the push function, and push function now simply adds an item to the array list, and add function on array list adds an item at the end of this array list. So array list is also an array but a dynamic sized array. It automatically grows and shrinks. So when you add, it adds an item at the end of this array. Now pop function, there is a get function in array list using which you can get item at any index. So we need to get the last item, and last item would be at index size -1. So we get the last item, right? We store it in a variable result. Now we remove the last item. There is a function remove on array list that takes an index and removes an item at that index. So we pass the last index, right? And we remove the last item, and then we return the item that we got at the end, right? Peek function, it simply returns the last item, and we can get the last item by passing al.size -1 as an index to the get function. Let's now see the size function. Size function is simply going to return what array list size function returns. So it's going to tell you how many items are there in the stack. So this is array list based implementation. This code also may not be handling overflow and underflow really well. We may write some if conditions and put the customized error messages and can return appropriate values and extend this solution. This solution also does not handle overflow and underflow conditions really well. We don't put any error message. We can add if conditions that we discussed earlier and handle overflow and underflow also. Let's now talk about time complexities of array implementation. So we have talked about two implementations. One was simple array implementation and the second one was array list based implementation. So if you are using simple array implementation, then time complexities of all the operations were big O of 1, right? And we were not allowed to add items beyond the capacity. If we are using array list implementation, the time complexities are still big O of 1 but amortized time complexities. In array list, dynamically resizing happens and there might be an operation which is costly, which is linear in time. So on average or amortized time complexity is big O of 1 here, because we are again adding an items from the last of this array. And if you have an array, whether it is an underlying array of array list or a normal array, and if you try to add or remove items from end or last of the array, your addition and removal, they both are big O of 1 operations. But in case of array list, there might be one costly operation. So we don't say worst case big O of 1, we say average or amortized big O of 1. So average amortized big O of 1 for all operations in case of array list implementation, and worst case big O of 1 in case of normal array implementation.